Okay, we'll try this again. As promised, here is a quick explanation on how to do pressure conversions. The analogy, the reason we spend so much time on it, and the analogy to temperature is because you need to kind of understand. You've covered elevation in survey for 3 semesters. I think you understand that elevation more or less expresses some amount of energy above or below some datum somewhere by the St. Lawrence Seaway back in 27 or 88. And pressure is going to express also some amount of energy over some datum. Same thing with temperature. All right, so to convert from absolute pressure, one side of absolute set of units to another, all you have to do is multiply by 1 since there is no datum shift. Any value divided by itself is 1, and you start to then know some of these basic equivalences and form the fewest number you can in your brain and then draw the connections using specific gravity or unit weights of fluids. So the ones that generally you should keep are 14.7 psi, which begets 2116.8 psf, 1 atmosphere for sure, 760 millimeters of mercury, and eventually that 2116.8, I'm sorry, the first conversion from 14.7 to 2116.8 is just that gross of square inches in a square foot. And then you can use the 2116.8 and the 62.4 unit weight of water to get to 33.9 feet of water. And that concept of head comes back all the time. And absolute pressure says how much more or less fluid than there is at 0 energy. All right, so that's gauge pressures can be negative, absolutes cannot. All right, to convert from one set of gauge pressures to another, again, there is no datum shift, so all you have to do is multiply by 1. Gauge pressures can be negative. That would be called a vacuum. So one thing you might realize is that all vacuums, if we start thinking about that, vacuums expressed in absolute pressure will have positive numbers because there's only positive numbers on the absolute pressure scale. But in gauge pressures, you can know whether something is a vacuum if, in fact, it has a negative pressure. Okay, and what does a gauge pressure express? It's how much more or less energy per volume there is than a fluid at atmospheric pressure. Going down through. Now, the slightly more complicated, but not so bad. To convert from one gauge pressure set to another absolute pressure set of units, you have 2 options. Either convert from one gauge pressure to the next by multiplying by 1 and then do a datum shift, or do a datum shift and then convert to the other by multiplying by 1. So you really have both options. How big is a datum shift? Well, go back to those equivalences. 1 atmosphere. Gauge pressure is 1 atmosphere absolute, so or the 0 for gauge. 0 gauge is 1 atmosphere more pressure than absolute 0 pressure. Here are a couple more of the most important equivalences to know. 33.9 feet of water. And because you already know 62.4 pounds per cubic foot, you can use this knowledge of change in pressure equals minus change in elevation times the unit weight of the fluid to get that 2116.8. That pounds per square foot is the base unit that we use. So the beautiful thing to know about the datum shift here in pressure is that the numbers for the datum shift also give you the kind of the conversion numbers. Don't memorize in the end. You might memorize that 33.9 feet of water divided by 14.7 is something like 2.3 or something like that. That's a number that a lot of people know, converting from a foot of head to amount of psi. So, but you're better off just keeping with the datum shift numbers so you don't have to carry too many in your head or in your black book. So here's an example. If you're going to convert from 14.7 psi absolute to gauge, you realize, okay, this is a datum shift. And then you have to realize that gauge is going to, the number for gauge is always going to be less because the datum is higher. It's up higher, 14.7 pounds per square inch. So you do a datum shift here, you go from 16.7 psi minus 14.7, and you get 2 psi gauge. Convert from 400 millimeters of mercury absolute to millimeters of mercury gauge. Well, first off, you start to recognize that that's a vacuum because it's less than 760 millimeters. So you know, you then do the more or less, and you get minus 260 millimeters of mercury, or a vacuum of 260 millimeters of mercury. When you see the vacuum, once again, you tend to know that that is then given in gauge pressure. Finally, convert 400 millimeters gauge to pounds per square foot absolute. First step, perhaps, is do a datum shift. In other words, you had 400 millimeters gauge, which means it would be 1160 millimeters absolute. And then you multiply by your 1. 1, in this case, jumping over the line with the 760 millimeters of mercury and putting on top 2116.8 pounds per square foot. You get an answer there of 3230.9 pounds per square foot. And that is the standard way to express pressure in terms of absolute. Force over area, using your basic standard units. Remember, pressure, like temperature, elevation, or velocity head, just expresses an energy level over some datum. If you are going to stick with one, stick with the one that means something, and that is the height over absolute zero. In other words, nothing on your pinky, no 1 kilogram, absolute or very, very cold, down to minus 273.15 Celsius or 0 Kelvin. That's it. We'll print it and put a few more out. Try to work some. There's infinite numbers. Calculators out there to do this, so one way to practice would be to just go ahead and use your, go to a site, think of a question, and have it selected. We'll put some more out once you've gone through the first quiz.